In this video, we're going to take a look at exponent rules. We'll start with the basics, and then we'll take a look at both negative exponents and fraction exponents. So let's start with, what does an exponent mean? So if you have x to the n power, the x is called your base, and the n is your exponent. And what x to the n means is that you have n factors of x. Let's take a look at it with a number. So 2 to the 4th power means you have 2 times 2 times 2 times 2. This one we'd simplify and say that it's equal to 16. Let's go ahead and take a look at some rules. Our first rule tells us what happens when we have x to the n times x to the m. And what you do with the exponents in this case is you add them up. Let's take a look at why this works. If we have x squared times x cubed, by the way, to the 2nd power we call it squared, to the 3rd power we call cubed. After that, you can just use the number. So the rule here would tell us that we're going to go x to the 2 plus 3. But let's backtrack and see why this works. So x squared would be x times x, and x cubed would be x times x times x. So you can see there that we got 5 x's, and that is why we end up with x to the 5th. Our second rule is what I call power of the power. So we got x to the nth. That whole thing is to the m power. So what happens here is you actually multiply your exponent. So let's take a look at this one. If we have x squared, that quantity to the 3rd power, we would be going 2 times 3. Let's take a look at why it works. Remember, x squared would simply be an x times an x, and you would have 3 of those. So 3 sets of x squared, and you can see that we end up with 6 x's. Before we move on to the next rules, let's go ahead and take a look at how this can become a little more complicated with 2 sample problems. On the left, we have 3x y to the 4th times 5x to the 7th y to the 10th. So on this one, we're going to be using our rule where we get to add the exponents. But be careful here. The 3 and the 5 are still just numbers. So the first thing we do is just 3 times 5. That's 15. But the next part will be adding exponents. We would have x, that's technically x to the 1st times x to the 7th. So that would be 1 plus 7. We would have 8 x's. And then y to the 4th times y to the 10th would be 14 y's. So there's our final answer. You can probably guess the most common mistake answer is you get so used to adding the exponents that you would write 8 for your number instead of the 15. Remember, the 3 and 5 are just numbers that get multiplied. All right, on to the next one. So we have 2x to the 6th y taken to the 3rd power. So we start with 2 to the 3rd. And that technically came from 2 to the 1st power to the 3rd power. We went 1 times 3. Now we go 6 times 3 to get the x's. And that would be x to the 18th. And then that y is y to the 1st. So 1 times 3 gives us 3. So that's a pretty good answer. But 2 to the 3rd is small enough that we can actually go ahead and calculate that. And 2 to the 3rd would be 2 times 2 times 2. Our final answer should be 8x to the 18th, y to the 3rd. Let's move on to our next rule. What happens when we're dividing exponents? So you might be able to figure this one out, because you know that if we went x to the n times x to the m, we would add the exponents. When we divide, we end up subtracting the exponents. So let's take a look. If we had x to the 5th divided by x to the 3rd, we could simply go x to the 5 minus 3, and that would give us x squared. But let's take a look at another example. What if we have this? Same numbers, but different position. This would give us x to the 3 minus 5, which when we subtract, we get x to the negative 2. But it turns out x to the negative 2 is often not considered simplified. So we have another rule, x to the negative n. What do we do with these negative exponents? Well, it turns out if you have x to the negative n, that's equal to 1 over x to the n. So to make the negative positive, you just make a fraction out of it. So if we have x to the negative 2, that can be 1 over x squared. And now we can go ahead and finish our previous problem. But to be honest with you, these two rules, I don't even like these rules. Next up, let me show you an alternative to this. So there's an alternative way to deal with fractions containing exponents. And the first step is to deal with your negative exponents. So if there are any negative exponents, you move to the opposite position. For example, from the top to the bottom, and change to a positive. So if you had x to the negative 4 and it's on the bottom of a fraction, you would just move it to the top and it would become x to the positive 4. So bottom goes to top and top goes to bottom, and you can get rid of any negative exponents. Step 2, if you have problems that are kind of complex, you want to simplify the top and bottom separately before you get to your final step, which is for the exponents with the same bases, you just ask who's winning, top or bottom, by how much, and this will lead to your answer. In fact, step 3 is all that you need for some of these problems. Let's take a look. So if we have x to the 8th over x to the 5th, there aren't any negative exponents, so you don't have to worry about step 1 or 2. Let's just look at step 3 here. Look at what we have and ask the question, who's winning, the top or bottom, and by how much? So it's x to the 8th on top, x to the 5th on bottom. The top is winning. It's 8 to 5. How much are they winning by? They're winning by 3. So my answer is x to the 3rd. I don't have to write x to the 3rd over 1. So yes, you can subtract, but I find it easier to just ask who's winning, top or bottom, by how much. This is especially true when you have a situation like this, where the bottom is winning. So we got n squared over n to the 9th. Instead of going 2 minus 9 and getting a negative exponent, which you have to simplify anyways, hey, just look at this and ask yourself, who's winning? Oh, the bottom's winning. It's 9 to 2. How much are they winning by? 7. So you get 1 over n to the 7th. When there's nothing left on the top, you have to have that 1 there. Let's look at one that's a little harder, that's going to use all 3 steps. So how do we start working with this? It's kind of your choice on what you want to do. Actually, step 1 and 2 can kind of be interchangeable. So I think I would start by figuring out what's going on top. So that's the power of the power. So I would be thinking x squared to the 3rd. I'd go 2 times 3 to get x to the 6th. Then that's y to the 1st times 3. I get y to the 3rd. And then I'll start dealing with the bottom. I'm not going to do anything with x to the 10th. It stays there. But my y to the negative 4th can simply go to the top and become positive. Now let's just take a look at what's going on with the x's and what's going on with the y's. When we look at the x's and we ask who's winning, top or bottom, by how much, there's more x's on the bottom. They're winning by 4. And on the top, now we're going to simplify the top and get y to the 3rd times y to the 4th. That's y to the 7th. So it's kind of a mix of simplifying and moving stuff around. But when you have to deal with something on top and something on bottom, you just ask who's winning and by how much. The last thing we're going to look at is what happens when you have fractional exponents. So first off, what does x to the 1/n mean? Turns out that that means you have the nth root of x. So let's take a look at something that you've probably seen before, just didn't realize it could be written in this way. 25 to the 1/2 power could be rewritten as the second root of 25. Now, when you first dealt with the second root of 25, you didn't see it that way. You simply had the square root of 25. So now you know that right there, square root of 25, could also be called 25 to the 1/2 power, or my personal favorite, radical 25. So we know what radical 25 is. It's 5. Why is that? Because 25 is equal to 5 times 5. And the 2 on the outside of the radical sign tells you that you need 2 factors of the same thing to simplify it. In this case, it would be 5. Let's try another one. 27 to the 1/3 power. This can be rewritten as third root of 27. We also call this a cube root. If we want to take a look at how to simplify this, we would go ahead and break down the 27 into 3 times 3 times 3. So the 3 on the outside of the root tells us we need 3 of something to simplify it. So that becomes 3 as an answer. This is the opposite idea of 3 cubed equals 27. The third root of 27 is 3. So the next thing we look at is, what if it's not a 1 on top? What if it's some other number? So if we have x to the mnth power, this can be rewritten as the nth root of x to the m. By the way, if you wanted to, you could also write it as the nth root of x to the m power, but usually the first one works out better for you. Let's take a look at an example. If we have x to the 6/3 power, this could be rewritten as the third root of x to the 6th. Now, if I go ahead and expand this, I get the third root of 6 factors of x. Notice that I need 3 of something to simplify. So I have one group of 3 there and another group there. So there's 2 groups of 3x's. So this would simplify to x squared. Well, now look back at the original. Hey, what's 6 divided by 3? 2. We could have simply simplified this fraction and gone to our answer, which is what you probably should do if it simplifies. But I use this problem to set up the next problem. What happens if we have x to the 7/3 power? So the setup's the same idea. We have the third root of x to the 7th. Let's go ahead and expand it. So there are our 7 factors of x. And we know that we need groups of 3. So we have one group there. We have a second group. So that would mean that we could put an x squared in the front. But notice in this case, we have an x left over, and that just stays in the cube root. So we have x squared times the cube root of x. 7/3 cannot be reduced to a whole number the way 6/3 was. And that'll conclude our video on exponent rules.